Right. So the last time we discussed how counting changes if we eliminate 9 from the list of numbers, right? And just how numbers become kind of weird. Like this now means 9, this now means 11, this now means 21, this now means 18. So numbers kind of get weird. And we also discussed why this is 18, because we kind of think of this as counting to 9 twice and then counting 0 more. So counting to 9 twice and then counting to 0 more, which makes it 18. And similarly, this would be like counting to 9 twice and then 4 more, so that's 22. So yeah, this system is the base 9 system, not the decimal system that we're used to using. This is the base 9 system because we have a total of 9 characters. So from now on, let's just to continue the theme of having no more rules to follow. The rule that we're breaking here is the number of characters that we use while counting. We used to have 0 to 9, we turned it into 0 to 8. And just to really decimate it, really, we're gonna now use only 2 characters, 0 and 1. We're gonna get rid of everything else, and we're gonna only use these 2 to do all kinds of counting. And we're gonna try to squeeze in some maths as well. So we're gonna try to add, subtract, multiply these numbers together. And also to eliminate confusion, I'm gonna start writing the base as a subscript at the bottom of these numbers. So this, if I'm writing, just to make sure it's clear that this is the decimal notation, I'll write a little 10 like this. And when I write a number with just ones and zeros, I'm going to write a little 2 to show that it's called binary, because there's only 2 characters. So let's try to count in binary, and let's switch colors because it's a different system now. We'll start from 0, simple enough. We'll go to 1, and already we are out of characters. We can't write this because this doesn't exist. So we need to get rid of this. And we need a new place value. And the unit's place value will be set to 0. So now this would be 2. And then we continue. This would be 3, and we're already out of characters again. So we reset both of these place values and we create a new place value and reset the others to 0. So this is 4. Yeah, it is 4. This would be 5. This would be, but I should probably explain what I'm doing here. This would be 5, and continuing with this pattern, I'm out of characters here. So I need to reset this to 0 and add 1 to the next place value. This would be 6, I believe. This would be 7. And again, I'm out of characters in all 3 places. So I reset them all to 0 and add a new place value. This would be 8, 9, 10, and so on. And I encourage you to continue counting like this just till this system is clear. This is, I think this is 14, 15, and finally we're going to go into 5 digits and end it here with 16. So this is how you'd count with just 2 digits, and you can count to the biggest number you can imagine with just these 2 digits. You can also add them and subtract them, but before that, let's reinforce conversion between these 2 systems. So just reinforce the logic that we use to convert between these systems, between decimal and binary. Let's get rid of that. So like we remembered, when we used to convert between base 9 and base 10, we would think of a number in base 9. Let's use a different count. We would think of a number in base 9. Let's use this for base 9. Right. We used to think of a number in base 9 as, oh dear. You should think of a number in base 9 as counting to a power of the base. To make it more clear, I would think of this as counting to 9 squared once. I would think of this as counting to 9 to the power 1 twice, and then I'd think of this as counting to 3 more. But for the sake of consistency and for the sake of having a pattern, I'm gonna write it as this, and this would be equal to 81 plus 18 plus 3. Oh dear. And that is how much? 102. And that's how I'd convert between base 9 and base 10. It's similar for converting between binary and decimal. So if, say, I have a number, let's use green because that's what I've been doing. Say I have a number 101101. I do the same thing when I want to convert to decimal, where let's count the place values. This would be 0, 1, 2, 3, 4, 5. So I would think of this as counting to 2 to the power 5 once, this as counting to 2 to the power 4 0 times, this would be counting to 2 to the power 3 once, this would be counting to 2 to the power 2 once, this would be counting to 2 to the power 1 0 times, and finally let's put some brackets so that to make things look cleaner. And finally this would be 2 to the power 0 once. And it's the same logic that I use here. It's when I think of this in base 9, it's like I've counted to 9 times to reach here, and that's why I think of this as counting to 9 times once. Kind of, that's what it means when I write this here. And then this place would be like counting to 9 twice, and so on. And it's the same logic here. Every time I add a new place value, it's like I've counted to a power of that number's base. So if I've reached here, it means that I've counted to 2 5 times, and because it's a 1, I've done it once. If it was 0, I've done that 0 times. So that's what I add. And if I add all of these numbers up, let's try to solve this. 2 to the power 5, that is 32, times 1 is 32, plus this is 16 times 0, that is 0, plus 8 times 1 is 8, plus 4 times 1 is 4, plus 2 times 0 is 0, plus 1 times 1 is 1. And if I add these up, that is 45. So 1 0 1 1 0 1 in binary is 45 in decimal. And that's how you convert between binary and decimal numbers. We're going to finish this with addition. We're going to try to add 2 binary numbers together because we've never done that before. Let's try to add 1 0 1 and 11. I'm going to go with this. We're going to try to add these 2. And no, actually I think this makes it more confusing than helpful, so we're going to get rid of this. We know these are binary numbers. So the same deal, 1 plus 1, that is 2, but we write 2 like this. So in fact we just write the units digit and carry over the 2's digit back up. Now it's 1 plus 0 plus 1, that is again 2. So I write down 0 and carry over the 1 from the 2's digit up. Once again it's 1 plus 1, so I write down the 0 and carry over the 2's digit, and this is the sum. I can check this in decimal. So if I convert this to decimal, what color we've been using for decimal? Orange, I think. If we convert this to a decimal, this number is actually 5. This number is 3. If I add these together, it's 8. And if we go back to our table, have we been writing the numbers? No, we haven't been tracking them together. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This was 8, this was 3, and this was 5. So I think it checks out. Yeah. And that's how you add binary numbers together. I encourage you to practice with more numbers. In fact, let's do one more problem right here, right now. 1011, and let's add 101 or 100. 1 plus 0, that is just going to be 1. 1 plus 0, it's just going to be 1. 1 plus 0, that's just going to be 1. And 1 plus 0, that's just going to be 1. If we want to check, this is equal to 11, I think. This is equal to 4 in decimal. And this equals 15. And if I try to solve this, it does check out. 11 plus 4 is equal to 15. So this is correct. We can do addition as well as subtraction. Let's try a subtraction problem as well, just because we can be done with it. Let's go with 1 0 1 0 1 1 and subtract 1 1 0 1 0 from it. If you subtract this, 1 minus 0 is just going to be 1. 1 minus 1 is going to be 0. 0 minus 0 is going to be 1. 1 minus 1 is going to be 0. 0 minus 1 actually works the same way it works in decimal, so I kind of carry over this here, and 1 minus 1 is equal to 0. So now I'm subtracting 2 minus 1, and now I'm subtracting 1 from 2, which is just equal to 1, and this is my answer. We can verify this. So if we convert this to decimal, it's gonna be 0 1 2 3 4 5. This is 2 to the 5th times 1, which is 32, plus this is 2 to the 3rd times 1, that's 8, plus 2 plus 1, it's equal to 43. This is to the 4th times 1, so that is 16. This is to the 3rd times 1, so that is 8. This is 2 to the 1 times 1, so that is 2, and that is equal to 26. And if I add 43 and 26, I do get 969. What do I get here? Is that correct? No. This is 2 to the 5th. Oh no, this is 2 to the 4th. 1 2 3 4. This is 2 to the 4th. So it should be 16 plus 1. That doesn't check out. What did I do wrong? Alright, I've been subtracting. Excuse me. This was not an addition problem, it was a subtraction problem. So if I subtract 26, it's going to be 17, and 16 plus 1 is equal to 17. So it checks out. Anyways, that's it for this episode.